Good evening, everyone. Welcome to the session. We'll wait for some time for people to join and then start the session. I hope you are solving questions after our sessions, because as I've already said, the number of questions that we are solving are not clearly sufficient, and you have to solve more number of problems to get used to solving. So, we'll wait for some time for people to join and then start. I hope you guys are seeing positive improvements in your CSAT performance. We'll start today's session then. So please take 3 minutes. Good evening, Shweta. Please take 3 minutes to solve the question that is displayed. I'll just start the timer. I've already started the timer. Please start solving the problem. And please post your answers. So there is one person has got them in option B. Others, please post your answers. Okay, one has got option A, one has got option B. Post your answers, others, if you're solving it. So two people have got option A, one has got option C, one has got option B. We'll see how to go about this question. So there is a numeric lock which has a 3-digit pin, and the pin contains digits 1 to 7. There is no repetition of digits. The digits in the pin from left to right are in decreasing order. From left to right are in decreasing order. Decreasing order. No repetition. And the digits is 1 to 7. Any two digits in the pin differ by at least 2. Any two digits in the pin differ by at least 2. How many maximum attempts does one need to find out the pin with certainty? So they are saying how many maximum attempts does one need to find out the pin, or the question is how many number of arrangements or the pins can be possible using the conditions that is given in the question. So they are saying that this is a 3-digit pin, and they are saying from the left to right the number decreases. From left to right, the digits in the pin from left to right are in decreasing order. So this would be the highest, then decrease, and then again decrease. And they are saying any two digits in the pin differ by at least 2. So they are saying that they'll differ by at least 2. So that means that can differ by 3 or also 4. Any two digits should differ. So I'll start with the leftmost digit as 7, and I'll go in an order 7, and then I have to give at least 2-digit difference. The other number would be 5, and after this the number would be 2 difference would be 3. Now 7, 5, and this can be 1. So there is no 0 here. The difference can be more than 2. Sorry, this is 2, and then 7, 5, and 1. This is the 3 combinations: 7, 5, 3. The difference is any two digits is 2 or greater than 2. Here between 5 and 2 the difference is 3. Between 5 and 1 the difference is 4. And this is one set. Then I'll start with 7 and 4. The difference here is 3. This is 2. This is the difference. This is 2. The difference is 2, and difference is 3. Difference is 2, and difference is 4. Here difference is 3. Difference 2 is 7, 4, 2. Then 7, 4, 1. So these are the only possibilities: 7, 4, 2 and 7, 4, 1. After that I'll have 7, then 3, and here it will be 1. So it will be 4, and then this is only 1. So if, this is with these are the numbers pins with starting with 7. Then if I start with 6, this number here should be 4. and this can be 2, 6, 4 and 1, and then this is the only possibilities, 2 possibilities here. And then if I start with 5, okay, no, so if I have 3 here, just a minute, I can have 3, 6, 3 and 1. This is also possible. Then I have 5, 3 and 1, and that's all. This is the only possible numbers because if I go to 4, the difference here should be 2, and the next digit would be, there is no 0 here, it should be 1. If there is 1, the difference would be less than 2. They are saying that the difference should be less than at least 2. Difference should be at least 2. So this number is not possible. These are the only possible numbers. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers which satisfy the conditions. So if, in 10, at least in 10 chances, one can find out the pin with certainty. So the answer is option C. I hope this is clear. People have got B and A. If you have any doubts, please let me know. Feel free to ask. So whenever you are writing these numbers, please do it in an organized way so that you don't get confused and you don't get wrong answers. Is there any doubt in this question? Okay, TAM. TAM and Beetle. Okay, so we'll move to the next question then, if there are no doubts. So take 2-3 minutes to solve the question. I'll just start the timer. And post your answers. There is one response for option D. Others, please post your answers. Okay, there are two responses, one for option D and one for option A. Others, if you're solving, please post it. Okay, we'll go through the problem here. We'll see how to go about this question. They're saying that there are 8 equidistant points on a circle. And how many right angle triangles can be drawn using these points as vertices and taking the diameter as one of the sides of the triangle? So let me draw a triangle, circle. They're saying that there are 8 equidistant points. One, this one. These are the 8 points. I'll just write it as A, B, C, D, E, F. They are saying that how many right angle triangles can be drawn using these points as vertices and taking diameter as one of the sides of the triangle. So if this GC is the diameter, this is the center of the circle. So if you draw, if diameter is one of the sides of a triangle inside the circle, that would be a 90-degree triangle, because the angle that is subtended by the arc or by the points on the center and the center would be twice the angle that is subtended. So if I draw this line, so this would be 90, because the points, this point G and C, the points that create this angle here, this angle would be half of this angle. This is 180 degree, this is 90 degree. And similarly, this would be one more triangle, 90 degree triangle. And even this is a 90 degree triangle. So similarly, the case with this 1, 2, and 3. So for 2 points GC, number of triangles, right angle triangle would be 3 plus 3, 6. Now similarly, for GC it is 6. For FB, it would be 6. For EA as diameter, it is 6. And for HD as 6. And then after HD, again GC will be there. So these are the diameters and these are the triangles, number of triangles. So total number of right angle triangles, the total will be 6 into 4, 24, 6 to the 24. The correct answer is option A. If you have any doubts, please ask. The number of triangles that can be formed, right angle triangles, with one side as a diameter is 24. Okay, so almost all the 3 have got, the other 3 have got option A only. So we'll move to the next question then. So take 3 minutes to solve this question. Please post your answers. There is one response. One has got option C. Two people have got option C enough. Others, please post. So now 3 people have got option C. Which will C. Okay, 4 have got option C. Priya. We have 4 people who have got option C. Others, if you have already solved, please post your answers. In the meanwhile, we'll see how to go about this question. Priya, if you have solved it, please post your answer. So, okay, see. So, 1 0-digit, 1 vowel, and 1 consonant from English alphabet are used in forming passwords, such that each password has to start with a vowel and end with a consonant. How many such passwords can be generated? There is one gray area here. They have not told whether the password is a single password or a double password or three-digit passwords. So normally, if if you have taken 3 digits, you will get the answer here. So it would start with a vowel. This is a vowel, and then it should end with a consonant, and then in the middle there would be a non-zero digit. Non-zero digit. Number of non-zero digit is 9. Number of consonant is 21. Number of vowel is 5. So you have to multiply this, you would get the combinations. 5 into 9, 9 5 is 45 into 21. 5 1 is 5, 1 4 is 4, 5 2 is 10, 5 4 9, 945. The correct answer is option C. I hope this is clear. So it is a 3-digit, say 3 alphabet or 3-character password. So almost everyone has got option C. So if things are clear, I'll move to the next question. If you have any doubts, please ask. If things are clear, please let me know. So I'll move to the next question. Okay. We'll move to the next question then. Take 3 minutes to solve this question. It's time. Please post your answers. Option D. There is one response for option D. Others? Others who are solving, please do it fast and post your answers. Others, what is the issue? I mean, there's only one response for option D. Others, who've got the answers, please post. Okay, now there is option 1 for option B, 1 for option D. Others, please post. So for 2 people have got option B, 1 has got option D. We'll see how to go about this question then. They are saying that there are 9 cups placed on a table arranged in equal number of rows and equal number of columns, of which 6 cups contain coffee, 3 cups contain tea. In how many ways can they be arranged so that each row should contain at least 1 cup of coffee? They are saying that 9 cups are arranged in equal rows and equal columns. So it will be a 3 by 3 arrangement, 3 rows and 3 columns. So the 3 cups will be like they are saying that there are 6 cups of tea and 3 cups of 6 cups of coffee, 6 C and 3 T's are there. So how to arrange? And they are saying that in how many ways can they be arranged so that each row contains at least 1 cup of coffee? There is 1 cup of coffee here at least, and they are asking in how many ways can we arrange this. There are 2 ways here. For example, this can be C and C. So all the 3 rows will have 2 cups of coffee. The other remaining is T. This is one way of arranging. And there is, in this also there is variation. I'll just cover that. Another variation is one row will contain all the coffees. The other row would contain 2 cups of coffee and 1 cup of tea. And this row will have 1 cup of coffee and 2 cups of tea. This is the 2 possibilities here, 2 arrangements of arranging these coffees. In this case, in this row, you can arrange it in 3 factorial divided by, this is 2 C's are common, so 2 factorial. This is 3 into 2 factorial by 2 factorial. This is 3 ways. This can be arranged in 3 ways. Similarly, this can also be arranged in 3 ways, and this can also be arranged in 3 ways. Totally 3 into 3 into 3, just 27 ways. So this, in this case, there can be 27 ways of how you can arrange the cups of tea and coffee. Now we'll see in this case how you can arrange it. In this case, each row has the same 2 cups of coffee and 1 cup of tea. Here it is different. In one row there is 3 cups of coffee. In another row there are 2 cups of coffee. In another row there are 1 cup of coffee. And this arrangement can be in 6 ways. How? In the first row, if you have all the 3 coffees, here it will be CCT, CTT. Again, this will be CCC, and then CTT and CCT. This is one more way. like one more way of arranging this 2 cups. I mean, I've just shifted it here. This I've interchanged it here. So like this, there would be 3 factorial ways. It is 3 into 2, 6 ways of arranging this among themselves, this row. So if you want, I'll just show it to you. C will be here. Then if I move this in the top, this will be C, C, T, T, C, C, and C, T, T. Then C, C, T will be here. C, T, T will be, I'll just interchange these two, C, C, C. And then I'll keep this C, T, T here. 2 cups of tea and 1 cups of coffee. And then after that, CCT, 2 cups of coffee, 1 cup of tea, and all the cups of coffee here. And then CTT, CCC, and CCT. So 1, 2, 3, 4, 5, and 6. So there are 6 ways like this of arranging these coffees of each rows. And then inside this row also we can arrange. So in the top row, where in this row where all the 3 cups of coffee are there, we cannot, there is only one way. So it will be 1. Here it will be 3 factorial because there is 2 cups of coffee same, 1 cup of tea is there. So 3 factorial divided by 2 factorial, that is 3. And then here also there will be 3. Because there are 2 cups of tea and 1 cup of coffee, so 3 factorial divided by 2 factorial again here because of these 2 similar teas. So this is 1 into 3 into 3, so 9. The total number would be, total is 6 ways you can arrange, and among inside that also you can arrange it in 9 ways. So total number of ways is 6 9s are 54. So in this arrangement, second arrangement type of arrangement, you would have 655 types. And here this is 27. So 54 is 27. If you add this, you will get 4 plus 7 is 11. 2 plus 1, 3. 3 plus 5 is 8, 81. So number of arrangements is 81. I hope this is clear. If you have any doubts, please ask. People have got option B. If you have any doubts, please ask. Don't hesitate. I hope this is clear. If you have any doubts, please don't hesitate. Please ask. If things are clear, please let me know. Both the ways, please let me know whether if it's clear or if you have any doubts. Three factorial is because this one row, there can be 3 rows. In one row, there will be 3 coffees. Another row, there will be 2 coffees and 1 tea. And third row, one more row would be 1 coffee and 2 teas. How do you arrange this? That is, you would interchange these things. So here, that's what I've showed here. 3 factorial is 6 ways. This is one way. The first row would have all the 3 coffees. Second row will have 2 coffees and 1 tea. Third row will have 1 coffee and 2 teas. Then I'll interchange these two. So first row will also will be the 3 coffees. Then the last row will be the second row, and second row will be the third row. And then I'll bring all the coffees in the middle, the second row, and the second row, 2 coffees row will come to the top, and then 2 teas will go to the bottom. And then I'll keep this same, and then I'll interchange these two. It is the fourth way. All the 3 cups of coffee will come down to the last row. 2 cups of teas and 1 cup of coffee will come to the second row. And similarly, 2 cups of tea and 1 cup of coffee will be in the first row, and then I'll interchange these two. There will be 2 ways here. I hope this is clear. So this is 6, that is 3 factorial base. Or else what you can do is, see, these are 3 combinations, 3 C's, 2 C and 1 T, and 1 C and 2 T. So let me call this one combination C1, C2, C3. So there are 3 combinations here, C1, C2 and C3, and there are 3 spots. So 3 into 2 into 1. So if you use one in the first row, if you use this one combination, the second row there will be only 2 combinations left, and in the third row there will be only 1 combination left. Total is 3 into 2 into 1. This is 6. This is also equal to 3 factorial. I hope Prajwal, this is clear. If you still have any doubts, you can ask. Don't hesitate. Others, is this clear? If you have any doubts, please let me know, or else we'll move to the next question. TAM, Anther, it's clear. Okay. TAM, is it clear? Beetle, TAM. Okay. We'll move to the next question then. So take 3 minutes to solve this question. Post your answers. There are 5 and 4 people have got answers. 2 have got option A, 3 have got option A, and 1 has got option B. Shweta, Tam, please post your answers. So we'll see how to go about this question. In the meanwhile, Vita and Tam, if you are done, please post your answers. So what is the number of numbers of the form 0.xy, where x and y are distinct non-zero digits? So x and y cannot be equal to 0, and they are distinct. X is not equal to y. So, and x would be from 1 to 9, y also would be from 1 to 9, and they are not equal. So this is no repetition. In this case, 0. X can be 9 numbers, 9 digits, that is 1 to 9, and after that, the remaining would be 8 digits. So the number of numbers that the form, it is in the form 0.xy, be 8 into 9 or 9 into 8, 8 into 72. Correct answer is option A, 72. Is this clear? People are approachable. Tam, please let me know if it's clear. Shweta. If you have any doubts, you can ask. If it's clear, please let me know. Shweta and Tam, is this clear? And others who are watching this, if is the solution clear? Okay. What they're asking is, they're asking what is the number of numbers of the form 0.xy, where x and y are distinct non-zero digits. For example, 0.12, 0.13, 0.14, like this. These two cannot be 0. Any of these digits cannot be 0. And these two would also be not equal. They should be distinct. There is no repetition. So in this, in the place of x, there can be 9 digits that can come. It is 1 to 9. 1, 2, 3, 4, like that. There will be 9 digits. And once this, you place the digit here in x, the remaining 8 digits can be used here. Because 1 is already used here, the remaining 8 can be used here. The single digits will be 0 to 9, that is 10 digits. 10 digits are there, but 0 you cannot use. And also the digit which is used in the x position also cannot be used. So there will be only 8 digits left out for the y position. So for x position there can be 9 digits, and for y position there can be only 8 digits. So total would be 72. 9 8s are 72. Will be of the number of numbers of the form 0.xy would be 72. That is option A. So like this 1.0.15, 0.16, 0.21, 0.22 cannot come here, 23, 0.4, like this. I hope, Shweta, this is clear. If you have any doubts, still if you have any doubts, you can ask. Sam, is this clear? Shweta, is this clear? Okay. So I hope things are clear. We'll move to the next question then. So take 3 minutes to solve this question. It's time. Please post your answers. Two people have got option A. Others who have solved it, please post your answers. And others who are still solving, please do it quickly and post your answers. Okay. Now 3 have got option A. Four have got option A. Okay. Most now everyone has got option A. You have to go about this question here. So how many numbers are there between 100 and 300 which either begin with or end with 2? So from 200 to 300, 100 to 300, sorry, 100 to 300. We're asking how many digits, how many numbers which would begin with 2 or end with 2. So we will see first which is end with 2, because from 100 it will be only the numbers which will end with 2. 1 is here, and this is one slot, this is the second slot. 2 would be here, and here in this slot, how many digits can come? 10 digits can come, that is 0 to 9. These are number of digits that can come here, and all these numbers would be ending with 2. So there are total 10 digits like this, 10 numbers like this. And now we'll see the 200s one. So the numbers start with the digit 2. Here this slot can get 10 digits. This also can get 10 digits. This is number. These are the possibilities. 10 digits here, 10 digits here. So this is 1 into 10 into 10 is 100. Total is this plus this, 100 plus 10, 110. Correct answer is option B. Sorry, option A, 110. I hope this is clear. And in this 100, there would be numbers which would end with 2 also. That is also counted here. So don't worry about that. So that is anyway counted here because the number is starting with 2 here. You don't have to double count it again because they are saying that either begins with or end with 2. And after 300 we don't check because it's only till 299, 300. So the number is 100 plus 10. There are 110 numbers. If you have any doubts, please ask. It's clear. We'll move to the next section. Next question. Okay, then we'll move to the next question. Take 3 minutes to solve this. It's time. Please post your answers. 3 people have got option C. Others who are solving, please post your answers. Please post your answers. So for almost 5 people have got option C. So we'll see how to go about this question here. How many numbers are there between 99 and 1000 such that the digit 8 occupies the units place? So they're saying 99 to 100,000. So effectively it is from 100 itself, because 99 to 100 there's no 8 here. So this is a 3-digit number. In 3-digit numbers, this unit should be 8. Here there should be 3-digit number, so 0 cannot come. The number of digits that can come is 1 to 9. The number of digits is 9. Here 0 can come, so it is like 0 to 9. Number of digits is 10. So the total number of digits with unit digits is 8 is 9 into 10, 90. This is into 1. There's only one digit here. So the answer is option C, 90. I hope this is clear. If you have any doubts, please ask. If things are clear, please let me know. I'll move to the next question. We'll move to the next question then. Take 3 minutes to solve this question. It's time. Please post your answers. There is one answer for option B. Others, please post your answers. And I forgot to wish you all a happy Buddha Purnima. Sorry, I just forgot it. So, happy Buddha Purnima to everyone. And people who have not yet posted the answer, please post. So now 2 people have got option B. Others, please post your answers. Now 3 people have got option B. So we'll see how to go about this question then. What is the total number of digits printed if a book containing 150 pages is to be numbered from 1 to 150? So number of digits is, so this here, this is the 3-digit number, 1, 2, 3. This is 3 digits. And you have to add all the digits that is printed. So how we would go about this is we'll segregate it into 1-digit number, 2-digit numbers, and 3-digit numbers. 1-digit number would be 9, that is 1 to 9. So this is 9 digits. 9 digits are there, and each number is 1 digit. So this is 9. 2-digit number 10 to 99, and the number of digits, the number of numbers are 99 minus 10. It is 89 plus 1. 99 minus 10 plus 1. There are total 89, 90 digits, 90 numbers which are 2-digit numbers into 2. And then 3 digits is from 100 to 150. Number of 3-digit numbers is 150 minus 100 plus 1 is 51 into 3. Of 9 plus 90 into 2 is 180. And 51 into 3 is 3, 5 is 50, 153. 3, 5 is 50, yeah. 9 plus 3 is 12. Then 8 plus 1 is 9, 9 plus 5 is 14. 1 plus 1 plus 1 is 3, 342. Correct answer is option B, 342. I hope this is clear. If you have any doubts, please ask. Is this clear? Okay, that is for counting. I'll just show you how it is plus 1. For example, if I'm counting from 1, 2, 3, 4, 5. So from 1 to 5, how many digits numbers are there? 1, 2, 3, 4, 5. How did I get that? That is 5 minus 1 plus 1. 5 minus 1 is 4 plus 1 is 5. So for example, if it is 2 to 8, number of numbers including 2 and 8 are 8 minus 2 plus 1. This is 6 plus 1 is 7. So how it is 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So there are seven numbers. Prajwal, is this clear? So the number of digit numbers from 99 to 10 is 99 minus 10 plus 1. Okay. Are there any other doubts in this question? If it's clear, please let me know. Pam, is this clear? Okay. We'll move to the next question then. It'll take 3 minutes to solve this question. I hope this is clear. So I'll just try to. I hope this is clear. Question. So please take 3 minutes to solve this question. Time. Please post your answers. Please try to do these questions in an ordered way. So whenever you are organized and you do it in an order, you would get the answers easily. without making any silly mistakes. So there is one response for option C, that is 85. Others, please post your answers if you have solved it. And if you have not solved it and if you are currently solving it, please do it fast and post your answers. Yes, please post your answers if you have done solving. What happened? Please let me know if others, what's the status? And are you still solving? Are you not able to solve? So, people are solving, please solve it quickly. Post your answers. So whenever you're trying to do these kinds of questions, do it in an organized way, in an ordered way. You would find patterns, and then you can extrapolate that and to find the answers. I'll solve this question here. But if you're doing it, you can continue doing it, and then you can see the solution afterwards. So I'll just solve it because it's already time. It's 9:20. Okay, there is one response for option D. Others, if you have done solving, please post your answers. In the meanwhile, okay, option C. We'll see how to go about this question here. So the question says that while writing all the numbers from 700 to 1000, how many numbers occur in which the digit at hundreds place is greater than the digit at tens place and the digit at tens place is greater than the digit at units place? So if I take ABC as 3-digit numbers, 700 to 1000, so A should be greater than B, should be greater than C. And how many such digits is possible? So it is starting from 700, so I'll keep 700 here. Here, the next digit would be 6. The digit at the 100 place is greater than the digit at tens place. So this is tens place. So this cannot be 7. This should be 6. And if it is 6 here, the number of possibilities here would be less than 6. That is from 0 to 5. So number of the numbers would be, there would be 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Total numbers will be 6 here. And now if I take 7, the next digit will be 5 because 7a is greater than b. Here the number of cases will be 0 to 4. Here it will be 5. See the pattern, you can see the pattern here. 7, 4, this will be 0 to 3. This is 4, 7, 3, 0 to 2. This is 3, 7, 2, 0 to 1. This is 2, 7, 1. This is 1. Sorry, this is 0. This is 1. After that, here 0 cannot come because here this number cannot be my negative. This is the last number. This is the numbers which are starting with 7 and where a is greater than b is greater than c. 6, 5, 4, 3, 2, 1. And if you are starting with 8, 8 also will have the same pattern. Here the number would be 7 instead of 6. Next it will be 6. Here it will be 0 to 6. Total number of this will be 7. Total numbers will be 7 here. So if you see the pattern, 6, 5, 6 plus 5 plus 4 plus 3 plus 2 plus 1. This is with numbers which are starting with 7. If I start with 8, this will be 6 plus 5 plus 4 plus 3 plus 2 plus 1. But here there will be 7. This one. And if I start with 9, this will be 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. This is the pattern. I hope this is clear. And now if I have to add all these numbers, I'll just add this. This is common here. 6 plus 5 plus 4. 6 plus 5 is 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 plus 2 is 20. 20 plus 1 is 21. 21, there are 3 here. 21 into 3 is 3 plus 63. And then this is 8 plus 7 is 15. 15 plus 7 is 22. 3 plus 2 is 5. 6 plus 2 is 8. The number is, total number is C, 85. I hope this is clear. So if you are organized like this, you can find out easily. You don't have to list it again for 8 and 9. You know that the next would be 6. Here again, this is 0 to 5. This will be 6. Then 5, 8, 5, and then 0 to 4. This is 5. So like this pattern continues. I hope this is clear. If you have any doubt, please ask. Okay, others, if you have any doubts, please ask. If it's clear, please let me know. Are there any doubts? If there are no doubts, we'll end the session here. We'll start tomorrow. We'll take tomorrow. We'll continue with the sessions tomorrow. And tomorrow would be the last session of permutation and combination, and also the last session of the maths CSAT problems. So tomorrow would be the last session for the things that we had started on March 8th. So I had told I think we'll be finishing by 6th, but we are just extending it by 1 day. So we'll end tomorrow. If you have any doubts, please ask. Or else we'll end the session here and we'll meet tomorrow at the same time, 8 o'clock. Is everything clear? People, do you have any doubts left? So we'll meet tomorrow then. Okay. So we'll meet tomorrow. Tomorrow will be the last session of the permutation and combination, and also the last session of the maths videos that we had started. So we'll meet tomorrow at 8 o'clock. Thanks for coming. I hope these sessions are useful. We'll meet tomorrow at 8 o'clock. And thank you. Have a good night.